decimal. Let me go ahead and record. So you have your decimals is making up 30 points today, and then IXL is making up another 20. So 50 total points for this assignment. And you'll see it there. Or we also just made, well, that's annoying. I just had it. Did I close that assignment? Nope, here it is. So we have this assignment here for number 23. Are there any questions before we jump in and get started on this decimal here? Yes, Ms. Yamanaka, I totally can. I also need to load it myself. So you're going to go ahead and click in here. Per usual, it's going to bring up this one here. I'm going to pop into my dashboard so I can see where y'all are at. All right. You can go ahead and log in. It should auto pull your name from your Google account. And then my computer's loading really slow. Anybody else going really slow this morning? Let me go ahead and get out of my slides here. Cool. You should see something like this. It should say out of 19 slides. Awesome. I see Christine has already like totally rocked this assignment out. Appreciate you, Christine. All right. I'm gonna have us be a little self-paced here. I want you to go ahead and move through. Our goal today is to, actually, I'm gonna pause you for a hot second. Don't go crazy for this moment. I wanna introduce this part here. Today, we're gonna be graphing exponential equations, okay? So you'll see the standard parent function here, which is y equals 2 to the power of x. An exponential function is any function that has x in the exponent, right? Makes sense. Exponential, x in the exponent, your variables in the exponent. It comes in this format when we are transforming things, right? So we have a times b to the power of x plus c plus d over here. And a, b, c, and d will all change how our graph looks, right? So a, b, c, and d are all going to change how it works, how it looks. So throughout the activity today, for all the way up to slide 13, you're going to be messing with A, with B, with C, and with D, like using sliders. They're going to be asking you questions about each of those. And we will like see what each of those does. I'm going to let you move pretty self-paced all the way to slide 13, right? All the way to slide 13. I may come on and make a suggestion if I see that many people are like having a struggle point or getting a question wrong. I may pause you at some point or direct you to a certain slide, but I'm going to try to let you be self-paced for this moment. Are there any questions about what we are doing before we get started? Can someone remind me in the chat, up to what slide are you going to? From slide 1 all the way to slide 13 for sure. So from 1 to 13, you're self-pacing. And why don't we do this? When you get to 14, let me know that you're at 14. Right, let me know that you're at 14. Cool. All right, go ahead and jump in. Miss Yamanaka, I'm still working on that link. It's just taking 90 years. Oh, hi, y'all. Thank you. Sorry, we don't have Galilee today, so I will hit you with a password in just a second. Thank you, Kimbo, for reminding me. Oh, good question, Devin. Hold on one moment. All right. Good question. So Devin is wondering, it's asking on each of the pages, it's asking some questions here. These questions are things I want you to think about on that page, but you will notice that on the next page, there'll be somewhere to actually type things in. So this question here is asking these questions are asking you to think about things, but I'm actually asking you to answer them on the subsequent slides, the next slide. Does that make sense, Doug? Cool. You can go ahead if it asks for a math answer, right? So something that can tell you what type of response I'm looking for. If you're on this one here, where it says like it has a bigger box, that's looking for question or like typing like a sentence type thing. If it is here and you notice that your letters start to be in italic, that means that it's just looking for a number, right? It will also give you a clue, like by using this little keypad here, it's looking for a number or an equation. So this is called like word text and this is math text. So if you're on slide 3, you just have to put one number here, right? One number, or you can put an equation here if you want. So one number. I'm here to answer any questions that you have. Y'all are doing great so far. Please let me know what slide you're stuck on. If you have a question, I'm happy to help. Christine, I left you some feedback on slide 14. I like what Melissa has written for this one here. Oh, that's not helpful. Which is the greater the value of B, the narrower or steeper the shape becomes. I really like that answer. And then something to note for the y-intercept, no matter what I do with the graph, my y-intercept does not change. This point here is 0, 1. It is not moving no matter what happens with B, right? If I change some of my other letters, that might change. But when I change B, it is continuing to go through 0, 1, 0, 1. You should have a 1 here, and you press submit. You should see something that says good work if you got the right answer. Right? If you typed something else like y equals 1, right, you'll see the same thing. If you typed y is the answer, it will tell you what's wrong, right? Because it's looking for just a number answer. Now we're thinking about changing b to less than 1, right? So still a positive number, right? Still has to be a positive number. But look at how the graph changes when the b is a fraction, right? Fraction or decimal. I'm loving Axel's answer here. Axel's answer is when b is less than 1, it flips across the y-axis. I love how concise that is, right? It's really flipping across the x-axis. I'm sorry, across the y-axis. Good job, Axel. Right, we can see if this is my original graph here, then 1/2 is going this way. Right. I also like Eric's observation that instead of getting steeper, it's getting flatter. Absolutely. Instead of going up, right, it's going down. Another way that we say this in mathematical terms, this is exponential growth, right? Over time, it is growing, and this is exponential decay, right? It is decaying, it is going down, decreasing over time, right? So exponential growth, and it turns into exponential decay. Absolutely. It never hits the x-axis. So we call this an asymptote. If you're looking at slide 6, we call this an asymptote when the line is getting closer and closer and closer and closer and closer to that number, but it never touches it, right? If I go to this graph, it looks like it touches here, but if I zoom in really, really far, I notice that no matter how far I go, even when I get here, I can keep zooming in, right? And it will never, ever touch the x-axis. It might get very, very close. Like, look how small that y value is there. But it is never going to, it's never going to touch. It will look like it touches, but it will never touch. Okay. All right. Keep going. Y'all are doing great. So think about, how does A change? How does A change? So this next question asks what happens when A is negative. What happens when A is negative? So when I go ahead and change A to a negative number, I see that it flips over to the bottom. I like the way that Araceli wrote this. She wrote, when A is negative, it flips the line below the x-axis. True. Turns into decay rather than growth. I like that Eric noted that the graph points down. It still gets steeper though, right? We can still make it go steeper, definitely. But it points down. The slope goes downward. Brandon's noticing it still seems like the slope is touching the x-axis, but it never does, right? If we zoom far enough in here, we can see, oh, there's still a difference between the x-axis and the line itself. Absolutely. So changing the A value, when it is negative, it flips over the x-axis. Now we're thinking about C. What happens when we change C? So on slide 10, you're talking about how C changes. All right. So C, we can see here, is moving our graph to the left and to the right, right? Moving our graph to the left and the right. I love that Devin shared that it changes the position of the graph, but not the shape. The shape is actually not changing. We're just moving the graph around our around the screen, around the coordinate plane. So it's changing positions. It's moving to the left and to the right. So the best answer for slide 10 specifically mentions moving to the left and to the right, a shift from the left to the right. We don't just want to say that it moves, but it actually moves from the left to the right. A really good answer would say, when I see what types of numbers move it there, right? So if I have -9, it's moving to the positive direction to the right. If I have +9, it's moving to the negative direction. It's moving in the opposite direction of what we see. And then finally, we're taking a look at B here. What does B do? on slide 12, we're talking about what b, the power of b. When you're ready, after you've answered slide 12, go ahead and move to slide 13. These answers are beautiful. A concise way of saying this would be D moves the graph up and down. Positive D moves up. Negative D moves down. One thing to mention with this graph, I'm seeing some solid answers here. We're going to start with y equals 2 to the power of x. Right? That's what it tells me to start with here. And then it says, what's the equation of this graph? So I know that when I have just 2 to the power of x, right, just 2 to the power of x, that's just going to be at 0, and it's going to move up this direction. So I see that the shape is correct. How could I move it down in order to have the asymptote not at 0, but down here? What number is that at? Yeah, negative, definitely Kimbo negative. And Brandon and Sadae, -3. For sure, I'm going to put -3 here. -3 there. Right, because I'm down. I know my y-intercept is at 2, but remember that's 1 off of your asymptote, right? So we want to look at where the graph is continuing. Like if we were going to say like it hits this number, right? Rather than saying it hits at -2, we're not talking about the y-intercept here. We're actually talking about where the graph, like it looks like it's going to like end, right? So where that asymptote is. So D is really talking about the asymptote. So here we're at -3. Awesome. Brendan, make sure that you've typed out the actual whole equation here. All right. As we're moving to 13, you're going to be able to see how they all move at the same time, right? A, remember, is going to be able to flip over our equation. B makes our equation flatter or more steep, right? Additionally, it can flip it over if we're over here. C moves our equation left and right. And D moves our equation up and down, right? So there are a lot of things that we have processed during this time. So what I want us to do is go ahead and go to slide 14. We're going to think about if this is the normal parent equation, how does the graph change if we do these things to it? So let's start with if A is negative. If we pop a negative in front, how does the graph change? How does the graph change? We pop a negative in front. We put a negative in front. Yeah, it flips. How does it flip? Flips over. Does it flip over to the bottom or does it flip over to the left? It flips down, yes. So we could say flips down over x-axis. Definitely. We want to be as concise as possible because we're going to use this as our cheat sheet for the next part. If B is a fraction, what happens? If B is a fraction, what happens? Anybody remember? If B is a fraction, so it's not going to flip down. It does flip. Which direction does it flip? It flips over the y-axis. Yes, Jonathan. It flips over the y-axis. So flips over y-axis, right? So when b is a fraction, it flips over. If b is a bigger number, what happens? If it was like 5 to the power of x rather than 2 to the power of x, what would happen? What's happening? It's like this nice, easy curve right now. What would happen if I made that number a 5 rather than a 2? Yeah, the curve gets sharper. I like the way that you wrote that. Thank you, Christine. The curve gets sharper, right? It gets like more like a L and less like a curve. Right? More like an L, less like a curve. Okay, if C is negative, what happens? If C is negative, C, remember, moves left and right. So if C is negative, do we move to the left side or do we move to the right side? Yeah, it moves to the right, right? Moves to the right. And I'm going to use a math word here, shift to the right. Shift to the right. So then what's the opposite of that if we have a positive number? Yes, absolutely. Thank you, chat. Shift to the left, right? It's going to move to the left side. So it's moving in the opposite direction, right? Like you would think positive, oh, it should go to the positive side. No, it actually goes to the negative side, right? It's opposite. All right. And then D is positive. This is usually our easiest one. If we have this, usually our y-intercept, but in this case, our asymptote. If D is positive, right? If D is positive, it goes up. I'm going to use the word shift again, shift up. And if D is negative, it shifts down. D is negative, it shifts down. Awesome. Great job, team. All right, let's go ahead and I'm going to open up the floor here. I want you to work through 15 through 19. 15 through 19, I'll pull you back or leave feedback on your page if I need to. 15 through 19. Ooh, let's actually all look at 15 really fast. Okay, so I'm going to teach you something kind of silly. Are you ready? Everybody silly? I made a video so you can see this silly forever. All right, I need you to take your right hand, wave your fingers. If you want to turn on your camera, that'd be cool. Take your right hand, wave your fingers. Now you're gonna make like the L, like the loser, you know, but it's gonna be backwards. So you're gonna take your right hand, make the L. Okay, you're gonna take it and you're gonna, this is so dumb. It's so dumb, but it's kind of awesome. You'll never forget it. You're gonna be like that guy over there, right? So you're gonna take your fingers, make an L, and flip your hand so that you're looking, what you're looking at should be the shape of the 2 to the power of x curve, right? Starting, and then it's growing as you go up, right? So this is the normal graph, right? This is the normal graph. So when I look here and I see -4, right? When I look here and I see -4, I'm gonna go ahead and flip my hand over because I'm gonna go ahead and flip my hand over because the negative, right? That negative is forcing my graph to move down, right? It's forcing my graph to flip over. So now I have the negative shape, right? The negative shape. And then I have the 1/2 here, right? The 1/2 is going to make my graph flip over the y-axis, right? So I'm flipping it over this way, right? So start with my right hand, that guy. This is my normal curve. The negative is flipping down. The 1/2 is flipping to the other side of the x-axis. And then the +5 here is shifting my graph up, right? Shifting my graph up. So I'm thinking, okay, it's not shifting up a half, not shifting up a half. must be shifting up 5. And I'm thinking when I started like this, I moved down and over, and I see this graph is growth, right? It's growth. It's going to be this graph here, right? So I'm looking at my hand to see which of those graphs matches what I have in my hand, right? Kind of silly, I know, but I actually think it helps. So you'll see on the assignment, I made a video of me doing this like dumb hand thing, but also looking at the problem here so you can see how my hand actually relates to the graph that's there. So it's a cute little video. You can check that out. Okay, let's go ahead and move to 16. Scotty loves it. I'm glad to have to say that to help. So here I have this one. If you start with that guy, right? If you start with your like little friend, right? You start with this guy. What moves did I have to do in order to make it turn to that direction, right? So if my graph normally goes up like this, right? I would need to flip it over, right? So it has to be negative. I see all of my answers are negative, so that's not helpful. And then I see that I want to flip it over the y-axis. I want to flip it over the y-axis. So I know that it needs to be a fraction. So it's either this one here or this one here. And then I see that it's up at +5. So I should have +5 as my answer. So I know that it must be this one. It's negative. Negative is flipping it down. Fraction is flipping it over. +5 moving it up. Right. So then you're going to explain your thinking on number 16. Explain your thinking on 16. Yes, Ms. Yamanaka also notices it does also look exactly like the graph on 15. So very, very easy to notice. I wanted us to see it in both directions here. All right. When you're ready, go ahead and move to 17. And then if you're finished with 17, feel free to peruse 18 and 19 at your leisure. When you're drawing a graph here, you can go ahead and draw your graph however you want. If you want to draw little dots, you can. If you want to draw like a line, you can. If you want to put an arrow, you can. Want to change the color, go for it. However you want to show it. Seeing some amazing graphs here. All right, in our last few moments together, I wanted to show you, this is awesome. So we can see like all of the different graphs here, but my favorite way to show this is with our overlay. All of our graphs are looking very similar, right? This is absolutely perfect. So we have our normal graph, right? Our negatives should be flipping them over, and then we should be shifting up to +6, right? So you should have a graph that looks just like that. It's looking awesome. I love it. Let me explain just what you're going to finish up. This is actually perfect timing. So your exit ticket is on your own. I probably should not show the answers. And so your exit ticket is 18 and 19. You're working through that on your own, 18 and 19. And then your assignment, your homework for today is your iExcel. The iExcel link is here on your assignment. And then if you want to watch me do like 4 or 5 problems with my hands, you can watch that video right there. It's like 2 or 3 minutes. So I'm glad that the hand thing is a lifesaver. Yes, I'm glad to hear that. Thank you for those positive messages in the chat. It is 10:30. That means we are done today. You're finishing your exit ticket. You're doing your iExcel. If you get stuck, we are having office hours starting right now. So if you want to stick around and work with us right now, you can. If you have Spanish right now, you can come back at 11:20, and we will still be here at 11:20 all the way until noon. So from 10:30 to noon today, we have some extra work time. Other than that, I love you all per usual. Please reach out if you have any questions, especially if something is looking funky. You let me know. Eric, sounds good. All right, I'll see you later. All right, bye. Adios, adios. Bye. Bye, y'all. Bye, David. Hi, Janet. You have a question or are you just still signing off? Oh, still signing off. Cool. Sounds good.
It just
All
ran
right.
away.